Party people. Today we have, again, three main goals that we're going to be going through. So number one, just like most of these arithmetic review classes we've done, we want to know how to tackle word problems, that general word problem strategy. We're going to be practicing it over and over again until it's cemented in. Because you'll see once you have the strategy cemented in, those formulas, keywords, they start popping out a little more. It makes things a little easier to digest. So number two, these are the topics that we're going to be handling in today's class for the most part. Number one, we're going to be going over general word problems. Number two, we're going to be going over percent word problems. And number three, we'll have systems of equations word problems. So before I continue, quick question. Of these three, which one would you say is the hardest for you? Which of these is the hardest for you? General word problems, percent word problems, or systems of equations? Some of y'all don't even want to spell it. You're just saying number three. All right, all of them. One, a lot of threes though. Percent, systems. Okay, so I'm seeing a ton of people saying systems. A lot of people saying those percent problems with systems as well. But it looks like we have a clear, difficult one right here in systems of equations. So for those of you that are a little bit familiar with them, but you struggle with them, systems are pretty hard. Like they're one of the more advanced topics for the simple reason being that, yeah, you have to know how to set up equations. Not only setting up one equation, but you have to set up two equations. Then, for some reason, these equations, you can't solve them by themselves. So you have to use both of them together some way, somehow. And then from there, you actually have to check your work to see if you're done because you could get two answers. So there's a lot going on there. So if you're saying number three, I totally agree with you. But I'm going to show you one of the more popular questions from systems of equations on the ASVAB that it's going to make a lot of sense as we continue setting it up, solving, setting it up, solving. We're going to get a lot of practice with that, and I'm really excited. So with that, cool. Thanks for those opinions. With that, before I continue, just a reminder, if you're in the program, general word problems, that's arithmetic reasoning, unit 1, percents is unit 4, and systems is unit 7. So for those of you, again, who are just joining now, who didn't get the spiel before I started recording, these are the units where you can find these topics. And just want to surprise you and give you a nice little update. Systems of equations, I've actually developed another 9 new questions with step-by-step solutions for each of those questions. So for those of you who are doing those speed drills and want more step-by-step feedback later this week, that's absolutely coming because I'm going to be replacing all of the questions in there with a brand new set of 2,500 questions, each of them step-by-step solutions. So hopefully you guys are excited about that because I pretty much go through the entire word problem strategy. What do you want? What do you have? What's the connection? And I actually solve the equations for you step-by-step in that feedback. So it's going to be really good for you. Look out for that email update. But if you're coming into class tomorrow, I should have a visual demo for you there. So lastly, hey, I got y'all, man. Get excited. So lastly, again, program members, I'm going to give you those reminders on how to move quickly, how to advance quickly throughout the program, throughout the courses. That way, again, you're not wasting any time at all, and you're making as much progress as you can with all the time that you have. So with that, there we go, my party people. So with that said, it's time for those word problems. So I want to go ahead and just engage with you all really quick before we get started. Number one, when it comes to word problems, everybody, what's the first thing you should always do? Pop quiz time, right? What's the first thing you should always do? And I see already a couple of folks saying RTQ. And that stands for read the question. The first thing you want to do in a word problem is absolutely read the question. So if you want to write this down, please do. Number one, what do you want? For every word problem, step one is what do you want? And that's, again, what's the question? You know, it's a great thing to know what you're going to be shopping for before you go into the grocery store, right? You know, we don't want to just go into the grocery store and let all these things, you know, come into your view, and then you start buying a bunch of things you don't need. I'm pretty much talking to anybody who has an addiction with Target. So number two, what do you have? So once you know what you want, that's when you're going to start shifting your eyesight to what's going on in the store. Because once you know what you want, now it's time to find what you need. So we got to make sure that we understand reading the question is way too important. Way too important is the first step. Because number two, once you know what the question is, you give yourself a really good opportunity to say, hey, okay, I want to find the cost of each hamburger. Your eyes are now going to turn to anything that has to do with hamburgers as opposed to being confused by that number or this keyword or this number or that symbol. So give yourself that opportunity to let the problem develop. What you have is all about the information. And number three, what's the connection? So this is where you set up a formula, set up an equation, set up your process. This is where you set up the math. This is where you set up the math. And then you solve it. So yeah, for sure. And that's totally fine because once you get that practice in setting up these equations, then you're going to get the opportunity to solve them. But my question to y'all is this. For those of you that have tried this strategy, for those of you that have tried this, have things gotten better or worse for you when it comes to word problems? Y'all tell me. Jameer, way better. Okay. It's helping. Better, better. Yes, I've improved a lot. Better, better. Yes, it's gotten better. It's helping much better. Okay, so look, there's no way that I can be all these people at once typing all these messages. I want to make sure that when it comes to like these strategies and these ideas that I take a long time going over, I want to be clear, this is not some gimmick or just like something that I'm putting in here. This is the most important part. Knowing these strategies and applying them over and over and over again, it's not a light switch. It's not like you get it or you don't get it. It's like the more you do it, the better you get. So it takes practice at your craft, just like any sport, just like any skill, any job. This math is no different. So the more time you put in, the better you'll get over time. So hopefully we're going to be open to trying this out because what we're going to be doing now is we're going to be going ahead and diving on in, trying practice problems out. And I'm going to give you exactly 2 minutes and 30 seconds per question. So allow me to go ahead. There we go, 2 minutes and 35. Just give you the extra 5 seconds there. And you should see a timer pop up right next to me in just about 2 seconds. Boom. Okay. So with that said, my party people, are you guys ready? Are you ready to try things out? Yeah, no worries. Welcome in. If it's your first class, you're going to learn a lot about this. Read the question first, then the information, then your setup. So we'll talk about how that actually looks as we get into it. All right, let's get it. And I think I saw someone saying that they had a question. Go ahead and type that question out. I'll reply to it as soon as we get the chance. Okay. I gotcha. So here we go. First question coming up. 3, 2, and 1. This might look familiar, huh? Get started. Good luck. We'll be back in 2 minutes and 30 seconds. Don't reveal your answer until the time is up. So we still have a minute 15 seconds left. Keep putting in the effort, keep putting in the work. And if you're confused, see if you can try to use those answer choices to your advantage. See if there's anything about this problem that you do understand that can help you get the job done. All right, and we're looking at our final 4, 3, 2, and 1. Go ahead, put those answers in. Take a guess if you have to. Take a guess, put a question mark next to your answer if it's a guess. No problem at all, guys. No problem at all. Let's go ahead and get my face back in here so I can help you out. Let's try it out. Let's see what we got, man. All right, so let me go ahead and close this up. Put my teaching hat on. Let's go. So, first of all, you guys tell me, in your opinion, was this an easy, medium, or hard question? In your opinion, was this an easy, medium, or hard question? And again, don't worry about it what anybody else is saying. If someone's saying easy and you thought it was medium, still say medium, you know? I want you to be honest. If it was tough on you, say it was tough. Yeah, this is a collective kind of brain trust here. So no worries at all. I'm being honest. Okay, so quite a few of us, there's a good group of us in the beginning here that answered first. I thought it was easy, followed by a more honest group of people that were saying medium, and some saying tough, some saying I'm just forgotten how to do it. Cool, no worries, let's try this out. So everyone, really quick, on the ASVAB, is it true that you can use the answer choices to your advantage? Is it true? Right, sometimes, for sure. You know, if you know what the situation's about, yeah, you can absolutely use the answer choice to your advantage. However, everyone, is it typically better to just know how to do the problem straight up? Typically? Right. Typically, it's good to know how to do the problem straight up. So here's what I'm saying. What I'm saying is there are 2 ways to solve this problem, and I'm going to show you both of those ways. One is going to take a more intuitive or common sense approach. And by common sense, I really mean, just using what you see to your advantage. The other way is going to be by setting up a system of equations. So again, for those of you that are looking at this is Arithmetic Reasoning, Unit 7. And this is, again, systems of equations. So if you want to write that down, feel free. Systems of equations. Okay, so let's go ahead and get into it here. My party people, here we go. Let's start by using those answer choices to our advantage. But number one, no matter what, we need to do what with every word problem? What's the first thing we do no matter what? Right, first thing we do is going to be read the question. That's the first thing we want to do. We want to understand what we're being asked to figure out. And that's right over here, my party people. What is the bigger number? Now, again, I'm not asking you to come up with an automatic solution. I'm just asking you really quick. Does that make sense, everybody? Apparently, we have some numbers and we're looking for the bigger one. Does that make sense? We got a bunch of numbers. We're just looking for the bigger one. Now, I'm not asking you if you know how to do it. I'm just asking you if that piece of literature right there makes sense. What's the bigger number? Cool. So, all right, let's write that down, either taking a mental note or writing it on paper. That's fine. I'm looking for the bigger number. Bigger number is blank. Okay, whatever. Now let's see if we can understand the situation. Okay, the situation says 2 numbers add up to 59. And then it says their difference is 45. Now that first part's pretty simple. It says 2 numbers add up to 59. So everybody, is it true that that would mean that we have like some number plus another number equals 59? Is that true? Is that what that means? 2 numbers add up to 59. Yeah, right? Thanks for agreeing with me there. Okay. The other sentence in green, the next sentence right here in green, their difference is 45. Everyone, what does the word difference mean? We have to understand that. What does the word difference mean? Landed, thank you. Yeah, difference meaning subtraction. So is it fair to say that in green, we could say that, the bigger number minus the smaller number equals 45? Is that fair? Is that fair? Okay, so if we have this understanding, and I'm going to ask you straight up, even if you were confused about this problem, did those parts make sense? Did it make sense in the first sentence that two numbers add up to 59? And did it also make sense that subtracting those same two numbers, you get 45? Did that part make sense to you? Okay, good, good. Because if you understood that portion of it, that context, then you're putting yourself in a great position to make that breakthrough, to have that light bulb moment. You're in a great position, so pay attention. So here's what we got. What we have here is, everybody, what are we trying to look for again? What are we looking for again? You remind me. Joshua, that's right. We're looking for the bigger number. Thank you, everybody. It's right. So what does that mean then? What do these answer choices represent then? Again, this is a very, very straightforward question, but I want you to answer it just to make sure we're on the same page. Everybody, these answer choices represent what? Yeah, the possible bigger number. We're looking for the bigger number. This represents these choices over here. These represent the bigger number. We just have to figure out which one of these is the right one. But again, these choices are representing the bigger number. So here's what I'm going to do. I'm going to pretend, or use the answer choices to pretend to have the answer. So I'm going to say, hey, let's grab 14. Let's see if 14 can work. Everybody, if I plug in a 14 right there, what number do I have to add to get all the way up to 59? What would the other number have to be? Right, the other number would have to be 45. Everybody, okay. 14 plus 45, is that 59? It is. It is. But if I went ahead and subtracted these numbers, is 45 minus 14, is that 45? Is that true? Is that true? No, that's not true. So before I continue, are we starting to see how the process of elimination strategy works here? Are you starting to see what we're doing? Cool. And again, I'm showing you the strategy for using the answer choices. I'm going to show you all four choices and find out which one actually fits. But then I'm going to turn around and I'm going to show you how to do it the straightforward way, because in many situations, the straightforward way is the faster way. Notice how this will get us the answer eventually, but it might take some time. So this will not work because, again, 14, the other number would have to be 45 to add up to 59. But if you take those same numbers, 45 and 14, if you subtract them, you cannot get 45. Not going to work. So because of that, that's not going to be the answer. We can move forward and try out the next number. Let's try 52. Everybody, if we tried 52, let's go ahead and highlight that in blue there. Okay, everybody, what number plus 52 gives us 59? That'll be 7. That's right. Okay, let's use those same two numbers. Everybody, is a 52 minus 7 equal to 45? It fits the bill. So 52 plus 7 does give us 59. 52 minus 7 does give us 45. So it looks like what we said about the problem, they add up to 59, they subtract to 45. These numbers work. Everybody, is that number 52, is that the bigger number of the two? It is the bigger number of the two. So that will work. Notice how we had another answer choice here. We had 7. 7 was right there. My party people, why is 7 not the answer, even though 7 works? Why is 7 not the answer? Because it's the smaller number. Exactly. It is the smaller number. So before I kind of go into the next way to do it, the second way to do it, is that making a little more sense to you? Is this a little more doable? Right on. I'm glad. I'm glad. But remember, the point of this is not to memorize the question and hope for the best. The point of this is to notice the strategy, understand the strategy, and keep it in your tool belt so that you can use it when you need it. If you try to memorize, you're hoping for a one specific situation, but when you understand, you see everywhere it can kind of apply to. So be careful there. I got you. Don't memorize, understand. So let's go ahead and understand, again, the other way to do this. So one way, again, was to use process of elimination. The other way is using algebra. And algebra is just a fancy way of saying representing everything with equations and variables. That's all it is. That's all algebra means. Writing it in math, quote unquote. So earlier, you know how we said, hey, blank plus blank equals 59? We kind of used a blank there, right? So instead of using a blank, we'll just use letters. We'll just use letters. And look at how cool this can be. So everybody, if we have two numbers that add up to 59, if it's okay with you, I'll say we'll use A and B. A for one number, B for the other number. So is it okay with you if I write it like this? A plus B equals 59. Is that okay with you? Great. Sounds good. So again, A plus B equals 59. Again, that is the first sentence. And let me erase all of this here to give ourselves a shot. Cool. So again, in blue here, again, the two numbers add up to 59. That's just me representing that. Second sentence, it says their difference is 45. So is it fair if I wrote it like this? Let's pretend that A is the bigger number. So if we did A minus B equals 45, would that make sense? Again, A is the bigger number. Does that make sense? Someone said, I started like that, but then I froze. Perfect. You know, I'm not saying perfect that you got it wrong or confused. I'm saying perfect because we just reached the point where you could have that breakthrough. Let's go. Let's see what we got. So we have these equations set up. Okay. Your next question might be, how do we solve this? Is anybody looking at this saying, hey, coach, I understand this, but how do I solve this? Is that running through anybody's head right now? Ooh, Landon, I see you've been studying. So my question again is anybody confused on where to go after this? Ooh, I love seeing more no's. I was expecting a lot of yeses. Okay. Okay, so for those of you that don't know, here's what we're going to do. Let me zoom in a little bit. What we're going to do is we're going to notice that, hey, look, we're looking for the bigger number. That's actually this right here. That's A. That is A. When we have a system of equations, everybody, a system just means we got two equations or more that represent the same things. Both of these equations have A, both of them have B. That's all that means. Two equations that represent the same thing. What we're going to do to solve this system is by taking away or eliminating one of the variables just so we can solve an equation with one. Because we can't solve this equation here by itself. Can't. You got two variables. You can't solve for one of it by itself. Same thing here. You got two variables. Can't solve it. But what I can do is I can actually take them together and I can eliminate the B. Watch this. If I add these equations together, help me out, everybody. If I add A plus A, what's that going to be? Okay, that's going to be 2A. Okay, sounds good. 2A. My party people, when we have a positive B and a negative B being added together, or B minus B, what ends up happening always? Yeah, it cancels out. If you have an equation and you have 5 and then you take away 5 from both sides, cancels out. If you have X and you subtract X from both sides, cancels out. If you have a B and you add a negative B or take away B, cancels out. So this is gone. And just to make it more clear in terms of that cancellation, let me erase all that. And then lastly, we have 59 plus 45. Okay, that might be a little bit of work, but let's go ahead and do it. 59 plus 45, 9 plus 5, that's going to be 14. 5 plus 4, that's going to go ahead and be 9. Carry that 1 is going to be 10. So we have 104. Okay. We're not done yet, though, because if we're trying to solve for A, all we got to do now is do what to both sides? Right. Now we just divide both sides by 2, and this is what opens everything up for us. We divide by 2 on both sides. That cancels out, and we're left with A equals 52. And remember, in the beginning, we said that A is the bigger one because if you're subtracting B, well, then B is the smaller one. So we said that we are using A as the bigger one. We got A equals 52. Are we done? Yeah, and we are done. The answer is B, 52. Now, I saw a question there saying, hey, are we always using the smaller one? Are we always trying to find the bigger number? No. They can give you any information any which way, my party people, any which way. It's really up to you to understand how to set up the equations from the words they give you. That's why if you're using the strategy of, let me just use the answer choices, well, you better be sure you know what those words mean in the sentence. You got to know what they mean because you have to know how to set it up regardless. So you see what I'm saying, everybody? No matter what, you have to know how to set up these equations to use the answer choices or to go through it algebraically like we did here. Either way, you have to know how to set it up. So when do we plug back into the equation? So Jocelyn, the reason that we're not going back and plugging into the equation is because remember, Jocelyn, the goal of this problem was to find the bigger number, right? It says find the bigger number. And here we set up A as the bigger number. So because of that, we don't have any more work to do. But if the question said, find the smaller number, then in that situation, we would continue by plugging the A back in so we can find B. Cool. Let me know if that makes sense. Jocelyn, iPhone, I saw you had the same question as well. Jared, I got you with the practice. You know I got you with the practice. All right. So with that said, who's ready to try a similar question out? Who's ready to try a similar question out? Nice. All right, cool. Let me just double check on my YouTube party people too. Hey, Kenneth, I got you with the variables. I got you. So let's go ahead and get into this next one here. So I want you to try this one out. Go ahead. I'm going to give you 2.5 minutes. Get started now. Go ahead. And don't give away the answer when you're done. Just go ahead and, hey, just say type ready in the chat box. Just type ready in the chat box. Let's see what we got. We still have a minute and 30 seconds left. We still have a minute, 30 seconds left. Do not reveal your answers. Do not reveal your answers. Give everybody a chance to try it out on their own. Do not reveal your answer. We still have a minute 15. All right, and time is up. Go ahead, share those answers. Put a question mark next to your answer if it is a guess. There you go. Put a question mark next to that answer if it is a guess. No shame in taking a guess, guys. No shame at all. Okay, cool. I see a lot of answers here. I got some different answers, got some patterns here. Good. Okay, I love this participation. First of all, this kind of participation is what's going to lead to success because you're going to be putting yourself out there, trying to do your best, trying to see what's going on, and then you're going to get the feedback. And with that, that pride that you kind of put out there, whether it hurts getting it wrong or feels really good getting it right, you're more likely to pay attention to understand the reasons why. And that's the most important thing. Whether you get a question right or wrong, always pursue the why behind it. So here we go. Before I begin, who here tried out using the answer choices? Who here, or trial and error, and who here tried setting it up with algebra? So who set up equations? Who used the answers? Who used equations? Who used the answers? You set it up, algebra way, equate. Okay, I see a lot of people using equations. I love seeing that. A lot of setting it up, equations, answers. I did both. Okay, great. So for the majority of y'all that are saying, hey, I set up the equations, that's awesome to hear. That's going to help you succeed long term. For those of you that are using trial and error, again, that's going to help you with like any last minute strategies or things of that nature. But if you know how to set up the equations, you're putting yourself in a much better position, not just to do this, but every other topic on the ASVAB. So here we go. So if we're going ahead and setting it up, here's what we would have done. For a sentence, it says two numbers add up to 129. So we can just say, hey, A plus B equals 129. Now, my party people, which one are we looking for again? A or B? Bigger or smaller? Which one are we looking for? Yeah, we're going to be looking for A, which we're going to just say is the bigger number. And we see that right here. It says, hey, what is the bigger number? What is the bigger number right there? So with that said, with my highlighter not working, we're going to go ahead here and say that A is the bigger number. I did not exactly. So with that part two here, their difference is 37. Okay, so everybody, which way is going to be the right way to write it? Is it going to be, let me highlight this first. Is it going to be B minus A equals 37, or is it going to be A minus B equals 37? Which one looks more correct to you? A minus B? Yep, and you're right. You're right about that. And the reason why is because if we say that A is the bigger number, then A minus B, yeah, that'll be a positive 37. If we did B minus A, it would still be 37, but it would be a negative 37 because a small number minus a huge number, always going to be negative. So we got to make sure we kind of think about how this actually makes sense. You can't do B minus A if you're saying A is the bigger number. It would be A minus B, so you can get a 37 as the difference. Exactly. One will give you a negative. So now that we're here, everybody, what did we say we could do? What was that E word that I said earlier? We are going to blank the B variable. Remy, thank you. We are going to eliminate or completely take out that B variable. It's called elimination. So what we're going to do here is we are going to go ahead, add these together. And we see that when we add these two equations together, my party people, look, we have A plus A, which is what? A plus A, which is what? 2A, exactly. And then what happens when we do positive B plus a negative B? What happens there? They cancel out. And then lastly, we have 29 plus 37. 29 plus 37, let's explore that real quick. 9 plus 7, that'll end up being 16. Carry the 1. 2 plus 3 is 5. Carry the 1 is 6. And then the 1 is right there, so it's 166. Great job. You guys already finished it before me. Good. All right. Now, what do we do as our last step? Right. Divide both sides by 2. Let's not get lazy there. Don't just say divide. We have to say by what and where. So we're going to divide by 2 on both sides because we have to get rid of the 2 right there. Trying to get rid of that. So here, let's zoom on in a little bit. Divide by 2. Divide by 2. Nice and easy. That's going to give us A equals 83. Now, do we have to continue here or are we done? Okay, we're done. Why are we done? Let's give a good reason why. Why are we done? Why should we not plug A back in to get B? Right, because we already said A is the bigger number. And because of that, because we're looking for the bigger number, we're good. We're good. So with that said, that's it. We're done. A is the answer. So Fiona, 83 plus 37 is actually not 129. 83 plus 37 is going to be 120. It's going to be 120. So it's a little different. So Fiona, I think what you're thinking of is, the sum and their difference added together is not supposed to give you anything at all. You're using those as relationships. Just adding 83 plus 37 to get 129. That's not what that means. That's not what that means. It's supposed to be 83 plus the other number. And we still haven't actually found the other number yet. But if we do a little bit of math, we're going to find out that that number is 46. Let me show you how. Right over here. Help me out, Fiona. I got you. No worries. So here, again, what did we say? We said that A plus B adds up to 129, right? So with that, what was A again? What was our answer? What did we get, everybody? Yeah, our answer was 83. So let's plug that in. So let me just highlight that. And we'll put the 83 right there. And then everybody, if we wanted to get B by itself, it looks like we're going to have to get rid of that 83. Everyone, how do we just get rid of a number that's just sitting there again? It's a positive 83 sitting there. What do? We want to cancel it out, but how do we do it? Jesse, that's right. We are going to subtract 83 on both sides. And so for the person who just asked in the chat box, privately asking, what if we had to find a smaller number or the other number? We plug it back in like we just did, and then we subtract this away. Boom, that cancels out, and we're left with B equals 129 minus 43, which is going to be a 6, and then 12 minus 8 is 4. And that's the smaller number because 46 is clearly smaller than 83. But yeah, that would be our smaller number right here. And that would be our bigger number right over there. So I saw another person, you're welcome. And I saw another person asking here, hey, coach, how did you get to 83 to begin with? What if we didn't know how to do 166 divided by 2? Well, this is going to be a great opportunity for you to practice your fundamentals. I got to make sure that everybody knows this. You can't wish your way a passing score on the ASVAB. You can't wish your way a higher score on the ASVAB. There are plenty of skills and concepts that you have to know that when you are putting yourself in a position to work on those things, you work on getting yourself a higher score. So if dividing by 2 is something that doesn't come naturally to you, I really recommend putting in time to do that. You can't succeed without knowing your fundamentals, which is adding, subtracting, multiplying, dividing with whole numbers, decimals, fractions, percents, order of operations, converting basic units, solving basic equations. Those are fundamental to every subject on the ASVAB. So make sure you know that. Yeah, Vicky, it's definitely possible for B to be the bigger number. We would just have to set it up accordingly. So if B is the bigger number, then it would be, A plus B does equal 129. But then instead of saying A minus B, it would have to be the other way, B minus A. Because if B is the bigger number, then it would be B, the big number, minus the small number. Their difference is 37. So it just gives you that setup. I hate word problems too. Not really, I love them, but still. All right, so who is ready to try another similar question out? Yeah, all right, cool. Here we go, my party people. 3, 2, and 1. Let's go. Try this one out here. Let me get this timer up for you. Let me get my picture out of the way. I'm starting the timer for you, but I'm going to answer those questions in the chat box right now. I got y'all. So let me see here. Dilver, definitely, he used that mental math. He used that mental math. Vicky, let me know if I answered your question there. Jairus, can you subtract and add? So, Jairus, I want to make sure I understand your question correctly. First of all, when it comes to equations, as long as you're doing the same thing to both sides, you're absolutely fine. Absolutely. Just not quite sure what you're saying when you're saying, can you subtract and add to the right of the equal sign for bigger and smaller? We'll see how that works out here. But again, as long as you're doing the same thing to both sides, you're fine. And then Keon, no, man, you can go ahead and make A the smaller, B the bigger. Just depends on what your preference is. You can use X and Y, A and B, M and N. It's up to you. But just make sure that when you set up the equations, it makes sense. The equations that you set up make sense. So keep up the good work, guys. We have a minute 17 left. Keep it up. And looking at our final 2, 1, and time. Go ahead, plug those answers in. Give me a question mark next to your answer if it's a yes. What do we have? What do we have? What do we have? Okay. All right. Sounds good. Sounds good. Sounds good. So let's go ahead and get to work, party people. First of all, let's read the question. What are we looking for? What are we looking for? Right. This time we're looking for the smaller number. This time we're looking for the smaller number. Okay. So what is the smaller number? Okay, cool. So here's how this is going to end up working. Just pay attention here. You want to pay attention to the setup because, again, it's not about memorizing the process. It's not like if I say look for the smaller number, it's going to be the same exact process every single time. That's not how this works. It's really a matter of understanding the setup. So we're looking for the smaller number. And again, we're talking about 2 numbers here. Are you guys cool still using A and B? Okay, sounds good. So for the sake of this question, I'm going to go ahead and, like some of you were asking, I'm going to say that A is the smaller number this time instead of saying that A is the bigger one. Okay? I'm going to say that A Oh, sounds good, Jairus. So I'm going to say that A is the smaller number. So again, this is what makes a huge difference. You saying what you want. I'm going to say that A is the smaller, and I'll say that B is the bigger in this case. So let's set it up. Let's set it up. First sentence, it says two numbers add up to 85. Can somebody give me the equation that we could use to represent that? Can someone give me the equation to represent that? Two numbers add up to 85, and we're using A and B. So what could we do? Yeah, A plus B equals 85. We can also say B plus A equals 85. Both of those are correct. 1 plus 2 is the same as 2 plus 1. Doesn't matter. So we could say A plus B equals 85 or B plus A equals 85. They both work. So I'll write that down. I'll write that down right over here. A plus B equals 85. And then the other way we could say is or B plus A equals 85. Either way is fine, guys. Either way. We'll pick which one we want in a second, because once we read the second sentence, it's going to say their difference is 45. Everyone, which way should we write it? If A is the smaller number, how should we write their difference? When you subtract the numbers, you get 45. Which way should you write it? Yeah, you should use B minus A, because if in this case, B is the bigger number. When you're subtracting, you want to use it first. So here in that case, bam, okay, cool. We'll write B minus A equals 45. Everyone, so far, do these setups make sense so far? Is the way that we're writing these equations making sense? Okay. Oh, excuse me. Let me write for that 45. Excuse me. Thank you for that. Appreciate that. That's 45. Excuse me. B minus A is 45. I'll correct that right there. Appreciate that. Feeling better about it. All right, cool. So just to go over it before we solve it. Number one, first sentence said, hey, two numbers add up to 85. So we can say that, hey, A plus B equals 85. B plus A equals 85. It's both the same thing. We're just saying the two numbers added up. That's 85. The second sentence, their difference is 45. This is where things, you got to really understand, what you are saying represents what. Because we said earlier, hey, we're going to say A is the smaller number, B is the bigger number. If we're subtracting them to get 45, the bigger number has to start first. Because if you did the small minus the big, that's negative, not a positive. They told you positive 45, so you're going to put the bigger number, B, first, minus A. That's how you get 45. So that part specifically, is this part in red here making sense? The reason why we put B first here, because we said B is the bigger number. That's why we have B first. That's really what I care about. If we're there, we're good to go. Yeah? Cool. Sounds good. So what we're going to do now is, well, let's try to solve for A. Let's try to solve for that smaller number. What do you notice? Well, if I went ahead and moved this right over here, if I took this first equation, my variables are already lined up. They're already lined up. The B is above the B, the A is above the A. What do we notice we can do if we add these equations together? What will happen if we add these equations together? What do you think? Yeah, we'll cancel out A. Let's see what happens here. Okay, if we add these equations together, we're going to get B plus B. Everybody, what's B plus B going to be? We're going to get 2B. Perfect. And then what happens when we do a plus negative a? What's going to happen there? What's going to happen there? Boom. Yeah, those are going to cancel out. So boom, cancels out. And then what's 85 plus 45? My party people, what's that going to be? 85 plus 45, 5 plus 5, that's going to give us 10. Then we have 8 plus 4 is 12. Carry that 1 is 13. So that's going to give us 130. Okay, cool. Now let's go ahead now and finish us off. We've seen the pattern. We'll divide both sides by 2. Let's do that there. Everybody, what's b going to equal? 65. Okay, so if we're sitting here, b equals 65 because 130 divided by 2 gives you 65. You can do long division, mental math, either way. That's what you're going to get. And we see 65 as answer choice C. Is that true? Is C the answer? We're good, right? Nope, we're not done. The reason that we're not done, everybody, is because we just solved for B, and we said B was the bigger number. Okay. And we are actually looking for the smaller number. We're not done. We found the bigger number, not the smaller number. To finish the job, everybody, what do we have to do? Jocelyn, you already had it. Yeah, we have to plug it back in. We got to plug in the bigger number and solve it to find the smaller. Here's what I mean. We can take any of these equations, and let me make sure that nobody's taking a picture of the wrong answer. We're going to go ahead and say, hey, look, remember, we said that these numbers added together, a plus b. We said that a plus b equals what? 85? 85. Okay, cool. All you got to do is plug in what you have. Everybody, we have b. B is what again? What did we say? B is what? 65, exactly. So we have a plus 65. And that's supposed to be 85. Excuse me, guys. Excuse me there. I got ahead of myself. So a plus 65 equals 85. And so once we're here, everybody, what is a going to be? If you're doing some number plus 65 to get 85, what's the missing number got to be? Boom. When we said it, a is the smaller number. And so in that case, once we take away the 65 from both sides, we ended up getting a equals 20. That is our correct answer. That is how we know we're done. Boom, boom. And D would be the answer here. Not C, not 65. It would be D, 20. So again, is this process, is this strategy for this type of problem making a little more sense? I'm for sure mistakes can happen. As long as you're able to correct yourself, you're good. My only thing here teaching is making sure that I'm putting the number in now, thinking about what's coming up next, making sure I'm communicating it effectively. So yeah, I'm prone to making mistakes for sure. Jared, yeah. So I actually am putting up all these plus more problems with more context up on the website. Yeah. Nice. And Celestine, welcome in. How often would you say this shows up on the ASVAB? So first of all, everybody, have you seen a question like this before? On a practice PyCat or the actual test? Have you seen something like this? So take a look. We got some people saying no. We got a lot of people saying yes. It can appear, might not appear. Remember, the ASVAB for the arithmetic reasoning, you are going to have, let's go ahead and say about 16 questions for the arithmetic reasoning, which is true. Do you think that they only have 16 types of questions in their bank? Or do you think it might be a lot more than that? Exactly. They have a ton. They have a ton of question types. So they have more than hundreds. I'll be honest with you. They have a ton. And so if you're feeling like you're studying for the ASVAB and you feel like your only option is to memorize questions, but then you get disappointed when you don't see those questions on the actual test, well, the reason that that's happening is because you're focusing on the numbers and memorizing as opposed to knowing the concepts. Because notice, I just gave you, 3 questions so far? All pretty similar, but I asked you to find different things. Now I could switch it up. I could show you another question of the same concept, like I will right now, actually. I could show you something like this. And this is what I want you to work up to. This is what I want you to be able to solve. Because if you can solve a question like this, then you're in a really good position to raise your score. Would you guys like to try this question out? Yeah? Okay. Go ahead. I'll start the timer. But remember, this is a same concept, same exact concept. But it's going to be a little tougher in terms of the context, in terms of the setup. This is what you got to worry about. All right? So with that, what we're going to do here is I'm going to give you the 2 minutes and 30 seconds. Give yourself that shot. Here we go. Timer is started. Go ahead. All right, and that is time. All right, so go and plug in those answers. Let's see what you got, man. Let's see what you got. Let's see what we have. So let me go ahead and get my face back into the frame here. Perfect. All right, so how would you guys rate this one? How would you guys rate this one? Was this standard, medium, difficult, hard? How was this? How do you feel about this one? Crazy, confused, hard? Okay. So what this is all about is a system of equations. Again, I gave you the same exact topic, same concept. Let me write this down for you. This is arithmetic reasoning, unit 7. And again, this is going to be System of equations. System of equations. So again, guys, like I know that this is feeling a little difficult. I know that this might feel a little daunting, but the more you stick with this, the better you're going to get at this. So before, no worries if you got lost, no worries at all. So before I begin the problem, I want to go ahead and just showcase on the back end here what this is going to look like for you. So allow me to go ahead and pull this up on my back screen here. And I'm going to show you exactly how, for those of you that are in the program, what you can expect later this week. So let me go ahead. Okay, so cool. And what I'm going to do, my party people, is I'm going to go ahead and share my screen. So give me 2 moments here. Okay. And there, cool. So it should be visible now. Everybody give me 2 seconds here. And you should be able to see my screen in a moment. All right, cool. Everybody, can you see my screen behind me? Yes or no? Cool. So this is what's going to come up again later on this week. So I kind of wanted to just show it here behind you or behind me. I'm going to preview what it's going to look like. So for those of you that are in the program, Unit 7, it's going to get a nice update this week. And here's what that update's going to look like. So it's not going to say exam. It's going to say all the fancy stuff, ASD, ASVAB, and all that good stuff. But after you start, it's going to give you sets of questions. This is the exact question that we're about to do right now. So here's the great thing that you're going to have to look forward to. So it's awesome that I'm about to go over the question with you, right? It's great to have a video, but you're going to want to practice a ton of these questions so you can practice with the different numbers, the different situations and words, and setting it up the right way. I think we can all agree with that. That's what we want. So when you take a look, yeah, sure, you'll go through the questions. Everybody, what do you think the answer is, by the way? What do you guys think the answer is? A lot of us put D there with question marks. What do you guys think the answer was? B, A, D. Okay. Got some D. Okay, I'll put D. And I'll go ahead and skip to the submission here. Cool. And we'll see if we got it right. Oh, we did. Great. But here's the great thing about what you're going to see when you're on the website. So notice, same question. Okay, that tells you the correct answer, but even better, boom, the explanation. What do we want? Okay, the cost of 1 hat. What information do we have? We go through in the setup. We say, hey, X is going to be the cost of this, the sunglasses. Y is the cost of a hat. And then we're going to translate the English into math together, showing you how to set it up, and then showing you, okay, once we have it set up, now here's how to solve it, step by step with every number from every question. And again, there's going to be over 250. Well, for this one here, it's going to be about 1,000 new questions actually for this one. And so we're going to plug all these questions in that are already sorted with the solution. And it's going to tell you step by step how to solve it. Every problem that you're going to see all the way through. And it tells you when you're done. And for the ones that you're not done there, for the ones that you have to plug back in, yeah, sure. It's also going to do that for you too. Every single question, every single time. It'll show you exactly what you need to do. So notice here, we get the answer for A, but in this case, for this question, we had to plug back in for B. So this is exactly what I mean. And you're going to see those same questions that we saw earlier. Oh, 2 numbers add up to 85 and their difference is 45. That looks familiar. And that's how we would solve this. Every step of the way, getting that correct answer of 20 that we got earlier. Again, my party people, is this something that you're excited about? Like getting the practice that you need and also getting that step-by-step feedback for every single question, because this is what the program gives you. Practice all ways that you need. So with that, yeah, I know it helps a lot, Landa. You've been crushing it lately. So thank you again for putting in that work. Let me go ahead here and bring us back into the frame. So I'm going to show you how to solve it here. But again, don't worry, because if you're in the program, when you start seeing these questions put in later this week, you're going to have not just the video from today's class, not just videos already of me going through practice questions, but you're also going to have the step-by-step for each question that you try every single time. So with that, here we go. First step, everybody, what are we trying to look for here in this question? Joshua, it's going to be Thursday. So the latest Thursday. I have to respond to everybody who's been texting me first. Once I catch up with that, then I'll work on advancing everything. Cool. We're looking for the cost of 1 hat. So again, remember, everybody, keep in mind, this is a slightly more advanced question, but it's still very doable. We want the cost of 1 hat. Okay. Everybody, is it okay with you if I say that, we're looking for the cost of 1 hat? So we'll say 1 hat costs, and then we'll just put a dollar amount and a, is that okay with y'all? That's what we're looking for, right? 1 hat costs blank dollars. Cool. Sounds good. So with that, does anybody here notice anything in common that this problem has with the other questions? Because in the other questions, we saw a bigger number and a smaller number and a bigger number. So 2 numbers, right? Here, we're looking for the cost of 1 hat. Is there a cost of something else that we don't know? Like, are they giving us 2 things that we don't know? Right, sunglasses. And in the chat box here, let's go ahead and keep it focused here. So with that, notice we're looking for the cost of a hat. And in the question itself, in the problem, we're talking about the cost of a pair of sunglasses as well. Everyone, do they tell us what the cost of 1 pair of sunglasses is? No, they don't tell us. So pay attention here. We have the cost of a pair of sunglasses, which they don't tell us. Then we also have the cost of a hat. They don't tell us that either. But apparently, it's part of the problem. When you have things like that, when you have 2 things that you don't know in a question, this is where you could potentially set up 2 equations, a system of equations. Again, all a system is, I'm not trying to scare you. All a system is basically saying 2 equations that talk about the same things. Watch what's going to happen here. Watch what's going to happen. Let's check out this first sentence here. Jason bought 5 pairs of sunglasses and 9 hats for $257. Everyone, let's go ahead and say, let's pretend that X is the cost of 1 pair of sunglasses. And then let's say that Y is the cost of 1 hat. So far, before I even continue, no worries, Jocelyn, I'm going to show you why this is not a proportion question. So everyone, is it okay with you if I do that? X, we'll say that that's the cost of 1 pair of sunglasses. Y, cost of 1 hat. Is that okay with you? Damien, I'll answer that in a second. Is that okay with us? Okay. So with that, here's what we're going to do. Read that first sentence. And think about this in real terms, in the real world. The first sentence in blue, it says, we bought 5 pairs of sunglasses. Everyone, if we're talking about the cost of that, if 1 pair of sunglasses is whatever, if we're buying 5 of them, will we not just do 5 times the cost of sunglasses? Is that fair? So yeah, if we're saying, hey, pair of sunglasses is X dollars, 5 pairs of sunglasses would be 5X. Is that true? Yeah. So let's write that down. Let's write that down right here. 5 pairs of sunglasses. That's going to be 5X. When we say 9 hats, well, that's going to be 9Y, because that would be 9 hats. And then what did it say, everybody? How much did we buy all that for? How much did we buy all of that for? Right, 257. So 5 pairs of sunglasses plus 9 hats, that's going to be 257. So that would be 5x plus 9y equals 257. Does that make sense in English? 5x plus 9y equals 257. 5 pairs of sunglasses plus 9 hats, that's $257. Does that make sense? Cool. So if that first part made a little bit of sense, this second part should make an equal, if not more, amount of sense. Watch this. Let's take a look at this next part here. In green, Joseph bought 10 pairs of sunglasses, 7 hats for $261. Is it fair if I said, okay, 10 pairs of sunglasses, that would be 10x, 7 hats, that would be 7y, and that total cost was 261, so I would write equals 261. Is that fair? Does that make sense for that green sentence? Yeah, exactly. We're using x for the pair of sunglasses because we don't know what the cost of one pair is. So we'll just say x represents the cost of one pair of sunglasses, and y would be the cost of one hat. And that's what's going to allow us to make these equations, to turn that English into math. Now, we're here. We have these two equations, 5x plus 9y equals 257, and then we have 10x plus y equals 261. We're looking at this and we're saying, okay, I know that these equations make sense. Is anybody here confused on how to solve them? Is anybody here confused on how to solve them? Yeah, and it's fair to be confused. Totally fair. This is what makes this a slightly more advanced question. Number one, we have actual context, not two numbers add up to this. Difference is that. No, now we're saying, hey, we're buying this item and this item for this much, this item and that item for that much. So we have to do a little more work there. Number two, okay, it's not perfectly lined up for us. It's not perfectly lined up in terms of, hey, just add them or subtract them when you're done. It's not going to cancel anything out. Nothing is the same. So here's what we can do. This is going to make things a lot easier if you look at it this way. So allow me to just take this. I'm going to move this out of the way. And I'm going to focus. I'm going to focus on this first equation, everybody. Everybody, is it true that instead of having 5, is it true that if we had 10, we could actually cancel these out? If this was a 10, could we cancel these out? If that was a 10, could we then cancel these out? Yeah, if that was a 10. But that's not a 10. That's a 5. What do we do? Here's what we can do. Watch this. This is totally legal. Everybody, is it true that whatever you do to one side, you do to the other? Is that true? Yeah. Whatever you do to one side, you should do to the other. As long as you follow that rule, you're fine. So what I'm going to do is I'm going to multiply the entire side here by 2. Multiply the entire side here by 2. So I'm basically multiplying the entire thing by 2, the entire equation. Watch what's going to happen, everybody. What's 2 times 5 going to be? Yeah, we wanted that 10. Okay. Everybody, what's 2 times 9 going to be? 2 times 9y, that's going to be 18y. Okay. And then pop quiz, what's 257 times 2? Let's do the math. It's going to be 514, but I'll do the math with you. I got y'all. 257 times 2. That'll be 7 times 2 is 14. 5 times 2 is 10. Carry the 1 is 11. 2 times 2 is 4. Carry the 1 is 5. So we have 514. Everyone, could we subtract these now? Could we? Yeah, we absolutely can. We absolutely can. And we will. We will, because watch this. I'll use red. If I subtract these, And again, I'm only focusing on these two right here. I can subtract these now because when I do, everybody, what's 10x minus 10x? What's going to happen there? What happens? Exactly, Jocelyn. 0. It cancels out. So that x is gone. All right, everybody. What's 18y minus 7y? What's that going to be? 18y minus 7y. That's going to be 11y. Thank you. And then what's 514 minus 261? What's that going to be? Some of us are throwing out 253. Let's make sure that we got that right. Let's just go ahead and double check here. 4 minus 1, that's going to be 3. 1 minus 6 can't do that, so we'll borrow. 11 minus 6, that's going to be 5. 4 minus 2, that'll be 2. So yeah, that'll be 253. Okay, sounds good. No worries if you forgot that we're subtracting, we're there. So now we have 11y equals 253. Let's just take a look at what happened. We got rid of the x. We eliminated the x. And when we eliminated the x, we made it so much more solvable. Because now all we have to do is divide both sides by 11. That's all we have to do now. Yeah, sure, you might say, Coach, how do you divide that big number by 11? That's not the question. The question is, do you notice that this is much easier to be solved now because we only have one letter? Do you understand that? This is easier to solve because we only have one letter, not two. Cool. So now that we're here, now we need to divide both sides by 11. So we have 11y equals 253. When we divide both sides by 11, we can do long division if you'd like to. Right over there. 11 goes into 25 2 times. And then you have 33. Everybody, 11 goes into 33. How many times? 3 times. So we end up getting y equals 23. Everybody, what does y represent again? What does y represent again? What did we say y represents again? What did we say? I'll show you the whole thing here. What did we say y represents? The cost of the hat. Okay, cool. Right here. Y is the cost of one hat. We found that y equals 23. Oh, because of that, are we done? Do we have our final answer? Yeah, we are done. We are absolutely done. The answer here is D, $23 for one hat. So, is anybody here looking at this like, Coach, I hate this? Is anybody saying, Coach, I hate this? Again, thanks for being honest. Okay, I'm going to read through these notes. I got y'all. I'll answer these questions. So here, first question is, could we have done it with the second equation instead? 10x plus 7y equals 261, or it has to be the first equation. So the only reason that I chose the first equation to multiply by 2, Jocelyn, is because I noticed that, hey, if I'm trying to solve for y, but I have a 5x here and a 10x there, if I double 5, I can get 10. Then I can eliminate. Because Jocelyn, if you would have tried to subtract 5x minus 10x, it wouldn't have canceled. You noticed that when we had 10x minus 10x, that canceled. That's what we were going for. But because we didn't have that, we had to do some modifications. We had to modify one of the equations to get that done. So let me know if it makes a little more sense there, Jocelyn. There are going to be several problems where you might prefer to modify the second equation. Plenty of questions where you actually got to modify both. Plenty of questions in that sense too. So let me know if that makes sense. Gotcha, Jocelyn. Let me go back to read this next one here. Thanks for the comments about me teaching better than most teachers. I appreciate that. I've been doing this for a while, hopefully. So let's see. Joshua, you got it. Perfect. Ramatul, tell me your question there. So Fione, the reason we subtracted the 18 minus 7y is because we're actually subtracting the entire equation from the other. So we had the 10x minus 10x, 18y minus 7y. So 10x minus 10x, 18y minus 7y, and then 514 minus 261. So we subtracted each bit from each other. So Fiona, let me know if that makes sense too. Definitely hate it. I got y'all. So with that, for those of us that are looking forward to practicing more problems like this, I would definitely recommend that you go through Unit 6 first, solving equations word problems, because once you get a good grip on solving equations, then you get a good grip on solving systems, then setting up systems. That's the 1, 2, 3. Solving equations, solving systems, setting systems up. You go through those 3 steps, you're going to be in a really good position. And if you want to take a picture, yep, feel free. I'm going to go ahead. Absolutely, Lila. Absolutely. So this is the 4th question of this type in today's class. So let me go ahead and get myself out of the frame here to take a screenshot. Feel free. Take your picture there. And then what we're going to do is we're going to go ahead and continue going over more questions. We still have 26 minutes in class left. Plenty of time here. Let's go ahead here and try a different type of question out, because this is as hard as I am okay with giving you all in today's class, just for the sake of keeping your confidence up. But let's go ahead and get into another type of problem. All right, so let's go and get into this next one here. I'm going to give you 2.5 minutes. 3, 2, 1. Let's go. Let's try another one here. And go. Timer has started, and I'm revealing it now. And again, this could be, oops, there we go. There's the timer. This could be a completely different topic, so don't assume that it's the same topic as always. Let's see what you got here, my party people. So some of you might be thinking, hey, I could go 1 month at a time and count 1 month at a time. Hey, if that works for you, it works. That's definitely one way to do it. But let's see if you can figure out a more guaranteed way. And looking at our final 4, 3, 2, and 1, my party people, what do we have? What do we have? Let's go ahead and bring myself back into frame and some water. All right, let's go go and get into it here. So, you guys tell me, is this question here that we just saw, is this easier, harder, about the same difficulty as what we just saw? What would you say? This is hard, easier, harder, middle, confusing. I feel like this is going to be super easy. I don't know what to do. LOL. I mean, Olivia, you tell me. Is it fair to say that everything is difficult until it's easy? You know, it doesn't start easy and then get more difficult, right? It starts off difficult, then it always gets easier. And the only thing that takes you from easy to hard or hard to easy is experience. So allow me to help you out by showing you what some of this experience can look like for you. You take that experience in, you grow, maybe get it right the next time. So let's try this one out here. So everybody, what is it that we're looking for? What piece of information are we looking for in your words? What is it that we are looking for? Go ahead, give it to me. In your own words, in a couple words, in a sentence, what is it that we are looking for in this problem? So, Jesse, to be a little more specific, not just any month, right? We're not just going to say January or February or March or April. They're asking, hey, what month was it 61 months ago? So the month that it was 61 months ago. So everybody, if we're saying, it's all good, Joshua. If we're saying 61 months ago, are we looking forward 61 months or backwards 61 months? Which way are we going? We're going 61 months backwards. Okay, so let's remind ourselves here, everybody. Let's list out the months just in case, we're just having a tough time remembering. So let's go ahead and list out a full calendar year. So help me out, everybody. First month is, help me out. Thank you. List them out. January, February, March, April, May, June, July. I'm going to need more room. Let me go ahead and give myself some more room. Boom. So July, August, September, October, November, December. Okay, cool. So just to make sure we got them all listed out in order correctly. Cool, we're good. And so everybody, what did it say the current month was? Current month is what? November. Right? If we can all list out all the months in order, I think we can all be happy about that, right? That's a passing score on the ASVAB. So here, we started here, and we want to go back 61 months. Does that make sense to everybody so far? We're starting in November, and we want to go 61 months ago. We just want to go backwards by 61 months. Okay, so I'm going to show you, like some of you have said, this problem seems difficult, but there's actually a very straightforward trick to this. And this is, again, where arithmetic reasoning or understanding strategy comes into play. So watch this, everybody. All right, we're trying to count backwards 61 months. Here's what we do. 1 month ago is October, 2 is September, 3 is August, 4 is July, 5 is June, 6 months ago is May, 7 months ago is April, 8 months ago is March, 9 months ago is February, 10 months ago is January. What's going before that? Yep, then we're right back to December for 11 months. And where are we 12 months ago? 12 months ago, we're right back at November. Interesting. Everyone, quick question. How many months are in a year? 12. So everyone, is it true that every time we go back 12 months, we end up right back on the same month. Yep. So here's the easy trick, or this isn't the easiest way to do it, but here's how you can make sense of it. Everyone, if we go back 12 months, we end up right back at November. We end up right back at November because that's a whole year. If we go back another 12 months, we end up still at November. If we go back another 12 months, we're still at November. We go back another 12 months, still at November. Everybody, we're trying to get back to what? 61 months ago? Okay, we're back to 48. If we go back another 12, how many months ago is that now? If we go back another year, where are we at now? 48, another 12 is 60, exactly. We end up still at November. We're at 60 months ago. We need to get to how many months ago, everybody? Yeah, we just need to go one more month back. And what happens when we go one more month back? Right here, minus 61. That is October. That falls on October. Right there. Right there. Did that blow anybody's mind in terms of how straightforward that could be? Did that blow anyone's mind in terms of how simple that can be? Okay, right on. And so here's a more favorable way to look at this. Another favorable way to look at this is by thinking about it as a remainder. Because everybody, is it not true that we were going in 12-month cycles until we couldn't anymore, and then we started counting the rest of the way? Is that what we did? We started going 12-month cycles, and then once we couldn't go any more 12 months, we started counting individually. So look at what happens here. If we have 61 months, right? We're going to see how many times 12 can go into 61. Look at what happens here. Everybody, how many times does 12 go into 60? 5 times. And so if it can go into it 5 whole times, so 12 months, 5 whole times, that's 5 years. But then what do we have left? When we subtract the 60, we have 1 month remaining. And what does that mean? What that means is if you're going back 61 months, you are going to go back 1, 2, 3, 4, 5 years, and then the remaining 1 month. And that's what gets you back. This is right here. That's what gets you back 61 months. You can just go 5 times. So 60 is just 5 years. Then you have 1 month left over. So you can start at the same month. Start at November, then go back 1 more month. The easiest questions are the hardest. I love hearing that. But there it is. This is what I call a modulus question, where the remainder is important. But you can have questions like this for weeks, minutes, hours. It all works just the same. And so if you're still confused, here's the idea behind the question. The idea behind the question is that what we're doing is if we're trying to count back 61 months, we don't have to go 1, 2, 3, 4, 5. We can use our knowledge that, hey, every 12 months is a year. Every year you repeat the same thing, right? So instead of counting 1 by 1 by 1, we counted by 12s a whole year because we knew we would end up in the same month. And once we got to 60, that's 5 years, still November. So to get to 61, we just went 1 more month back. And that's what got us to October in that question. So I'm going to mark the answer there. Again, the answer is A, October. And this is going to be part of Unit 1. Unit 1, General Word Problems. General word problems right there. Okay. So with that, who here would like to try out not a general word problem, not a system problem? Who wants to try out a percent word problem? Who wants to try a percent word problem? Okay, cool. Let's go ahead and get that set up for us. And so again, this is part of the update that we had 2 weeks ago. So these problems, you're going to have 15 of these exact types already in the program, again, with those step-by-step solutions given to you. So let me go ahead and pull this up for you. All right, here we go. 2.5 minutes and go. And that is time, my party people. There we go. Put those answers in. What do we got? What do we have? And put a question mark next to your answer if it is a guess. As always, guys, no worries. So let's go ahead here and perfect. All right, cool. So this is a different type of question, right? This is a percent word problem. And so we can find this in unit 4 under percent word problems. So this is AR unit 4. And this is again is going to be under percent word problems. Booyah. Okay. So everyone, here's the thing. When it comes to, like I say all the time, when it comes to every topic, every concept on the arithmetic reasoning, there's a main idea behind that concept. And there could also be a formula. So when it comes to percents, first you need to understand that there's a formula. Here's the formula right here. The formula that you're going to be using is the percent times the original equals the result. And so when it comes to this formula, there's actually going to be a main idea that goes along with it. Who can tell me what the main idea is for percents? What is the main idea for percents? That's right. So those of you that have been to my classes, boom, there it is. The percent that you apply is the result that you get. So all that means is this, everybody. I'm going to highlight this for you because I don't have much time left, but we have percent here and result there. The percent that you apply is the result that you get. So in this question, when we are looking for how many pieces are currently in place, well, guess what, my party people? This percent right here says successfully positioned, 1 second, successfully positioned 64% of the pieces. So when they tell you that you have 64% of the pieces in place, when you apply that 64%, that's going to give you the number of pieces in place. So right there, in place. Cool. So this is the thing about percents. The percent that you put into the formula is going to represent the same idea as the number you get at the end. So since we plugged in 64%, and that represents the percent of the pieces in place, when you do all the math, you're going to get the number of pieces in place. Yes or no? Does that make sense? So that's the big key there. So once you have that big key, booyah, you're good. So what we're going to have now is just making sure that we're plugging in the right original. And what you plug in for the original is the whole thing, the 100%. What's there from the get-go, from the beginning? What's that beginning total amount? And that's right here. It says the project requires 9,600 domino pieces. So let me actually not confuse the heck out of y'all and use green. The project requires 9,600 domino pieces. That's the original amount. It originally required 9,600. So booyah. We plug that in, and that's what's going to give us our answer. So it seems like a simple setup, but you have to know where these pieces come into play. You have to know, because if you don't, you're not putting yourself in a good position to succeed. So with that, remember all of these types of questions as well were also put into the program. You have all the step-by-step solutions, but let me show you how to go ahead and do this one here. So here, everybody, when we multiply by percents, we first have to turn them into what? We got to convert them into a decimal. That's right. So 64%, what does that turn into? 0.64. That's correct. So boom, you move that decimal place over once, twice to the left. So that's going to be 0.64 times 9,600. And that's going to equal, again, the number of pieces that are in place. Now that you have that there, we're set. We're going to go ahead and actually multiply, and we're done. So here, 9,600 times 0.64. And what we're going to do is we're going to ignore the decimal, and we're going to bring that decimal back at the end. So here we go. So here's 0 times 4. That's going to be 0. 0 times 4, that'll be 0. 6 times 4, that'll be 24. 9 times 4, that'll be 36. Carry that 2, that'll be 38. Plug a 0 in. 0 times 6, 0 times 6. Then 6 times 6, that'll be 36. Then 9 times 6, that's going to give us 54. Carry the 3, that'll be 57. All right, so now we have 0, 0, 4, 14, 11, and 6. Everyone, what do we do? What do we do to finish this up? What do we got to do? Right, we're going to bring the decimal places back. So that'll end up being 1, 2, 1, 2. So that'll be 6,144 pieces that are in place currently. And there, boom, that'll be B6144. So does that make a little bit of sense here, my party people? Are we good on this type of question? I appreciate the love. So Joshua, the way that I know to multiply or divide is by knowing that, hey, I'm looking for the result, so I got to multiply the percent times the original. But if it was a different situation, if it was a situation of, yo, I'm looking for the percent or I'm looking for the original number, well, then I got to divide because I got to take out the other thing. So it's really a matter of understanding the setup, understanding, hey, the setup, if I'm looking for this, I do this. If I'm looking for this piece, I do that. You know, it's really about that. And if you're comparing also to tax and discount questions, that's exactly why I added these types of questions in to make sure you know the difference between the regular percent questions, tax and discount questions, simple and compound interest. I got to make sure you know the difference between all these things to make life easy. Yeah, to find the final cost, quote unquote, Jocelyn, you're talking about tax and discount questions. Yeah. So I would definitely make sure to go to the new recording that I put into the program, into Unit 4, go to percent word problems. And on top of that, you can go ahead and go to the lesson videos that I added right there in the middle for basic percent word problems. And then I also added in a speed drill that you can practice on your own. And then I also added in these questions to the unit checkpoint. But if you go to Unit 4, in the middle, you'll see percent basics word problems. That's the lesson you want to go to. Yeah, exactly, for sure. Delvere, yeah. Some questions are definitely easier than the others. Absolutely. So as we wrap this class up, I'll let you get a chance to screenshot that. But how are you guys feeling? How are we feeling? Feeling good, better? Do we understand that, again, it's not a matter of, oh, I study once and I'm going to pass. It's really a matter of, hey, how much better can I get with time? Can I get a little bit better, a little bit better, a little bit better at a time? That's really the biggest thing. Because at the end of the day, like I said in today's PSA, your attitude really does matter. Your attitude of, hey, I'm not quite there yet versus, this is impossible. Those make a big difference in how you approach your studying. It's always possible. It's just a matter of how long or how much practice it'll take. So put in the time, put in the effort, enjoy what you can of it, and then keep moving forward. So as always, my party people, I love y'all. Unfortunately, we don't have enough time to go over one more. It's 7:59 already, so I do have to end it there. But for those of y'all, because I literally had a ton of questions here today. But I do have to run because I do have to take care of my health. I am still jet lagged by about 4 hours, so I do need to try to get some rest. But with that said, my party people, I love y'all. If you are interested in the full program and you don't have it, text me right there, 567-698-8867. Just let me know, like, hey, coach, I was in your class. I'm interested in the program, and I'll go ahead and give you a discount to the program. On top of that, if you are in the program, again, the questions that we went over today were for Unit 1, general word problems, Unit 4, percent word problems, and Unit 7. So 1, 4, and 7. Number 7 was systems of equations. And so, like I told you earlier, later this week, you're going to have a nice treat. We're going to have about 14 new types of systems of equations problems in your program, all of them with step-by-step solutions. So again, that's 14 types of questions. That's going to add up to well over 1,000 questions once I plug them all in. So I already created them all. They're there. I just have to finish writing the solutions for all of them. And once I have them, boom, they're all yours. So with that said, my math party people, I love y'all. Tomorrow's class is going to be solving equations. So get ready for a fun one there. It's going to be a really good one, especially since I told you to get systems of equations down, you've got to know how to solve regular equations. So get ready for that tomorrow, my party people. Again, if you are interested in the program, shoot me a text right there, 567-698-8867. Let me know you're interested in the program, and I will give you a discount code. So with that, my party people, you guys have been absolutely amazing today. You guys have a great evening, and let's keep acing the ASVAB. One day better, one day at a time, guys. I'll see you tomorrow. Cheers.